testing, testing. I believe we are live. Let me go ahead and start off. Double check. Sweet. Let me go. Where did we do that document? The dev stream. This one? No. If you are joining, we are going to get started in a minute or two, giving people some time to jump on. Right now, I'm just going over, grabbing some charts, so we have something to look at while we talk. Let's see. Yes. That's so funny. My fiance just messaged me to ask if I was wearing my tooth. That's the kind of week I've been having. So, give you some sense. Man, for the life of me, you know what we're going to do? We are going to pull up an old chart. I got about another minute here, and then we're going to kick this off. All right, it's 11:05, so thank you for tuning in. Let me just go ahead and open up chat real quick, make sure that I'm not missing anything. Wave to the camera. Okay, most. Sweet. We are good to go. So what we're going to do this week in the dev stream. Last week, if you were here, you remember that we kind of went over a high level of, from host all the way up until application. What does that look like? And the reason we're doing this, obviously, is I'm trying to give a full stack perspective on what it means to actually, build and raise. So if you don't know anything about me, I've been a self-taught dev for the last 20 years, and I've been fortunate to be able to work on every stage from, I built a manually editable HTML kind of like little Facebook file for my 7th grade class. And then since then, now I do full stack systems, and I've been able to touch everything from Kubernetes clusters to CSS and everything in between. And part of this process for Capstone, obviously, we did a fundraise, a friend and family round back in 2021. And so I've had a lot of time to think about this kind of intersection between product management, building good tech that scales, building it in a way that, investors understand what's going on. And so trying to synthesize all that information is difficult. And normally that's split across a team of people. And so I think it gives me a unique perspective, and that's what I want to share with you guys. So last week, we basically talked over everything here. If you weren't here, I'll give a very high level summary, which is that code that you write is hosted somewhere, usually in a cloud provider. This could be something that you provide yourself. Generally, though, this is something that another service provider will bring. And then obviously you have above that some type of infrastructure. Now, the key here is this infrastructure allows you to basically see or not see, but interact with the servers themselves, right? So in this case, I gave some specific examples and kind of walked through the process of how someone might start with something like AWS or Vercel or whatever, and click around a dashboard, and then eventually try to automate that so that things are easier to manage on day to day, and then eventually move towards a system that's entirely written in code, right? And so that's the key point here. Now, above that, we have this, you'll hear it called source control management, source code management. Sometimes you'll hear it called version control software, VCS. But basically, whenever you talk about GitHub or Git or GitLab or any of these providers, then this is basically the way that you can version software. So I went in, a fair amount of depth on all this, and basically how you go from code that you write and push to something like GitHub, how that code runs through this CI/CD. If you don't know what these words are, this just means continuous integration and continuous deployment. Basically, it means we take all the code that you wrote, we bundle it all up in a certain way, and then we deploy that to servers, right? That's the gist of it. So that's basically what we covered. And we pretty much skipped over this entire process here in terms of managing app and data back and forth. So we're going to touch on bits and pieces. But what I thought about doing instead of just walking through a diagram like we did this week is I wanted to explain this from the perspective of actually building a little educational funding portal. So let's say that you were trying to raise money for something and you weren't happy with any of the existing portals that were out there, right? What would you do? So we're going to talk about this, and specifically what we're going to do is approach this from the perspective of how I would actually try to address each layer of the project, right? So if we're looking at this, and let me toggle preview mode, live preview. Gosh, why am I struggling so hard right now? Whenever I'm like live streaming, it feels like basic things I do 1,000 times a day, I forget. It's okay, we'll just disable. We're going to talk about everything from host layer. So what we discovered in this diagram, right? We're going to start, we're going to work our way up here. But instead of what we did last week where we started here, we're actually going to start on the app and data integration side and go from there. So let's talk a little bit about your, first and foremost, your workspace. When you are organizing code, you are trying to think, how do you actually manage this, right? Now, the reason this matters is that you're trying to think, how do I easily access this? So we use a really old program I wrote years ago called RepoGen. There are better solutions now. I use it out of habit. But basically, if you go to, what is it, npm, I forget what my package is, package, we go to repo Genesis CLI. So, it's been 5 years already, it's crazy. So I wrote this, this project, which basically all it does is it allows you to pass in a simple configuration. Of course, this is now defunct. It's been too long, I guess. I don't know what happened to it, but I can show you a live version. So if I go to, say, our RepoGen here, you can see that I basically just provided this provider, which is referring to your SSH config. And if you don't know what that means, you basically have a file in your .sh/config directory, which I'm not going to open up. And what this does is it basically says that you can specify a provider name. For example, if I were to do, if you've ever used Git before, if I do something like git clone at github.com, my/my repo, you can do this. You can also do, for example, change this to a provider like CapsOne or my random provider. And so when I say provider here, really, this is just an alias for thing that SSH config recognizes and will alias out or use as a synonym to say, use this specific config. And the reason this matters is I can basically take this provider, point it to an SSH file, and when that happens, now it'll automatically reference. Now, the advantage of this is that basically you can create a config structure that works across. So instead of having to rely on individual creds, or there's some other ways of managing this, I like that you can basically pass this provider, pass it in a list of repositories, and then it will go through and basically symlink that for you. So whenever you're in your terminal here, terminal is just this big black window. It's just special kind of app. that you can run if you've never used it. If you go ahead and open up your Spotlight, if you're on Mac or if you're on Linux, then you don't need this explanation, I assume. But basically, there is an app called Terminal. I'm using something called Kitty, which is a different GPU accelerated terminal that I like. And you can see that there's some additional information I get from there, right? Now, the big thing here is if I'm looking at this, all of these, if I were to say change into API, you can now see a bunch of related services that we have here, right? And if I were to say go to, let me go ahead and pull up the Caps One repo. We'll do OFC price proxy. You can see now that we have a file here, OFC account proxy. And if we look over at, where is this? OFC price proxy. You'll see that we now have files that link to that, right? So this, the significance here, actually, let me just do a grep on this one. So you can see that in this list of files somewhere, I don't know why I struggle to read so much when I'm streaming, but anyways, you can see that you basically can access that repo. So what does that matter? Why did we go through that? Well, when you as a developer are working across projects, one of the first things that people are going to tell you to do generally is you want to start with this concept of a mono repo. Now, why do you do that? Well, the simple reason is that people want you to have a really, really simple kind of starting point that encompasses all your code in one place. Now, there's a reason that I don't do that. And most of it has to do with code encapsulation, security. There's a bunch of like random boring reasons that we're not going to get into. But what I want to do is show you what is one way that you would potentially get started with this. Now, most people jump straight into the tech. I think that that's important, but I also think that before you start making some of those key decisions, it's important to start kind of chipping away at, okay, how do we actually understand what's how a developer would potentially organize this. And most developers, just to be clear, they don't care about this, right? They don't think about this. They just go, well, I can run a generate command. For example, if I was starting a new project, they would say, get a repo. Let's do demo. And they would do something like bun create next app. And they would go through, create the app. And now, if they changed into that app, they could then run it. Let me do bun dev. And now you would have, in a very short period of time, once it finishes compiling, a working app. So this is actually an app, and we could go through and deploy this to Vercel if we wanted to, for example. But this is a deployable item now, or artifact. So one thing that people will do is they will basically combine everything, their API, their app, all of it in one place. And with Next.js in particular, which is a React framework, you'll see this pattern of an app directory, and you'll see we have an API directory where we can basically combine our backend with our front end in one code base. Now, I just mentioned some words, which if you're new to development and you hear something like Next.js and React and all these things, you probably have heard those on the web, but you might not understand why one is advantageous over the other. What most people will do at this point is they will try to pill you on their stack, right? Now, we have a stack that works for us, but there's a tool for each job. And what I would like to do is walk you through some of the considerations and how we think about each of those tools. So last week, if you were here, you'll remember that we talked about some core ideas. For example, we talked about vendor agnosticism. We talked about performance, speed, network latency, vertical scaling, horizontal scaling, etc. We talked about, I actually don't know if we got into high availability and replication, things like that, but basically we talked about how you make sure that data is available even when shit hits the fan, right? And you'll hear people talk about replication, streaming replication, etc. Like there's a bunch of words that people throw around, which all generally means I want to back up my stuff, right? And we can give it a bunch of different words, and there are different use cases for each. But at the end of the day, I know that I have code or state that lives, if you think of this from a blockchain perspective, like the state is represented as a series of blocks, and those blocks are comprised of transactions, and those transactions boil down to some type of hash data, right? And that hash data can then be reproduced linearly throughout the state engine. And so the value of that is pretty obvious. I can look back at any point in time and determine that, you know, the sky is blue, you know, and someone else tried to say, no, the sky is green. And I can look back and say, no, it says right here, the sky is blue. Everyone agrees the sky is indeed blue. Now, whether you're doing this from a single database perspective, like, hey, this is my database, I can run this locally, or I can run, you know, my database on top of a cloud, right? So this could be like, for example, Postgres on AWS, right? This could be SQLite. We'll just stick with the same SQL Postgres on localhost, right? So Postgres is just if you've never heard of it, a type of SQL database. It's open source, and it's largely overtaken what was previously the incumbent, which is MySQL, which was pioneered by Sun Systems, I believe, and purchased by Cisco. Someone correct me on that in the notes. But anyways, point is that this is, you know, generally the process you'll see is that people will go from data or some type of app or code running locally to something that's replicated on the cloud, right? So let's go back to this thing. And now you're probably at this point, and I did this partially because I'm ADD, partially to kind of illustrate the confusion in jumping around, right? If I'm in a workspace and trying to get started, and then I want to bring in code, and now I have to think about React and Next.js, and I have to think about all these different things, what I'm doing is getting further and further away from a very simple mental model, right? And simplicity is great. Things that aren't simple are usually a result of a person who has way too much, you know, information, trying to simplify that. Or on the flip side, it's also just the result of people not understanding something, and then them trying to like work around that with complexity, right? Which is, you know, you see both of those. Now, what I want to do here is talk about this app that we have. So if we were trying to build our little educational funding portal, first and foremost, we need a place to start storing the code. So we talked about, okay, I know that I'm going to write some code, and I'm going to have a way that I can then reference that workspace, right? In this case, we've said, you know what? We don't want to deal with a workspace with a bunch of repositories for this one. We're just going to deal with one repo, right? That's very simple. We can wrap our heads around it. We don't have to think about anything else. Cool. Next thing is, I want to know that I can store this. Why? Well, because if I do git remote here, you'll notice that this remote is pointing to a sandbox directory or repo, and that's intentional. This is basically where I put throwaway code whenever I'm testing something. So, and this is a private repo. But if I go and let's say git init, let me pull this up a little bit, and I do git init. Now, if we check out the remote for this, you'll notice that there is no remote. Now, what is a remote? A remote points to something in the cloud. So if I were to say, look at GitHub/allochp, and I were to look at repos, I could basically look through, and I don't know what I have in here, so I'm not going to scroll down, but you can basically go through and see all these available repos. So if I click in a sandbox, you can then see GitHub allochp sandbox, right? And you'll notice that this matches what we saw locally, right? So if you've done any sort of development, that doesn't even remotely surprise you. But what we can do instead is that you'll notice we have now this different branch. We could then add something like git remote add origin, and we could add, for example, our sandbox, right? And now you could see that we have our sandbox as a remote. Now I'm going to go ahead, just for the sake of simplicity, I'm going to remove that git workspace because we don't actually need it. We're all going to store this in the sandbox. But just to illustrate that you can create a separate repo and post it wherever you want, right? Now, we have our little app, and our question here is, what do we do to actually run this? Right, we know how to run the Next.js portion, but we need to be able to store data from that app. In other words, like if I were to change, if you've never inspect elemented something before, let me show you this. So if I were to come in and change something, like for example, Next.js, hello world, I've edited the state, so to speak, or what you would call a DOM element in the browser. But if I refresh, first this has to be running. if I refresh that, in root, what you'll notice is it goes back, right? And it doesn't matter that the server was not running while I did that. If I did hello world again, it doesn't matter. And if you've done, even if you're not a dev, you've run inspect element for a joke or to artificially elevate your P&L so you can flex to your friends or whatever, you know that doesn't stay, that doesn't persist, right? So the question is, well, how do we persist? So we talked about databases, but the reason we're doing this particular stream is not just to say use the stack, it's to think about how we come to the conclusion of using a stack, right? So if I'm looking at something like Postgres, why would I want to use Postgres? Well, first and foremost, it's free and open source, right? And so one of the considerations when you're looking at a new project is I want to go and see, I actually don't know what Postgres is. Oh, nice. I want to see what their license looks like. So a few things I'm checking here for anyone, even if you're not a dev, you know this off the bat because a lot of crypto projects are, use GitHub stars and things like that, contributors, number of forks, et cetera, as an indication of success. You can actually buy these. So always be wary when you see a project with like a bunch of stars that you've never heard of. In the case of Postgres, it's a very legitimate, robust, well-supported community project, but high stars can be like high follower count on Twitter, not necessarily an indication of actual traction, right? But in this case, Postgres is a very legitimate project. We use it at CapSwan. Hundreds of thousands of organizations use it. I don't know how the number, you'd have to Google that, but a lot of people use it. So if I were looking here, what I'm going to do is check out the license, right? And you can see copyright and license information can be found here. And now if I wanted to dig into that, I would then determine, let me see if did they move this? Let me pull up, copyright. This is not what I want. Let me pull up something that I do want to talk about itself. So this is a project we're going to talk about in a minute, but I'm going to use our license to kind of illustrate a point. If I come to a GitHub project, I can see immediately what project they're using, and then I can get a sense for the permissions that are available from that license. And there's some limitations, liability and warranty limitations, don't mind, but I can use this commercially. I can modify, distribute it. I can use it for patent. I can use it for private. So this is a very permissive license, right? Significance here is that, you want a project, if you're going to be using this foundationally, to not get caught in the open source trap. The open source trap, you can see, for example, with Redis or Elasticache or Mongo, there are these very large organizations, and what will end up happening to them is they will start out free and open source, right? And then eventually, after they go free and open source, they'll say, hey, we are going to lock this down for profit. Now, this is good on the surface, right? You want an org, I don't know, good on the surface. There's some legitimate reasons to do this. You want paid organizations to support this. And the bottom line is that open source doesn't get a lot of financial traction. So just because a lot of people use your project doesn't mean that a lot of people are paying you for it, right? And I'm sure you've seen that XKCD meme where it's the entire world of software and it's balanced on one block that some solo dev in Kansas is running. SQLite, as an example of this, is the most used database in the world. It's basically a local SQL file-driven SQL database. So similar to Postgres, but different. And it's really, really lightweight. It's become more popular in recent years. And the significance is that, 3 devs maintain that, and it's, used by millions. And so there's this very weird problem. And again, I keep saying millions, again, fact check me on these numbers. I don't know the exact usage numbers for SQLite or Postgres or anything, but they're very, 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 very popular, right? So when someone says lock this down for profit, the advantage is that these orgs then can sustain themselves. The downside is that then you end up where, let's say, for example, we have a couple clouds that we use, and one of them is DigitalOcean, right? Now, an org like Redis, so let me actually move this up so we match. An org like Redis or Elasticache or whatever will come along and they'll make some changes. We're going to focus on Redis because this was the biggest upset recently. People are talking about it. So Redis comes in and says, hey, we are going to now change from our existing free and open source license that our founder wanted to something different. So they now come up with a license that basically says you can use this unless you are reselling this, right? And I'm sure there's more legal stipulations to this, whatever. But basically, the thing that they're cracking down on are other vendors, other cloud vendors reselling Redis. Now, why would they do that? Well, the reason that they do that is that there's Redis, the database, and then there's also Redis, the company. And Redis, the company, or Redis Limited, or whatever their name is, you can check it out yourself. They say, hey, we have a cloud of our own. And if we look, let's go to redis.com. You can see that they have, for example, a pricing page, and you can get started with their database. Now, what happens is that companies like, whatever, Terso, or I actually don't know if Terso uses them, but like Upstash, I know for a fact uses them or used. And you'll notice that, for example, they have this Redis database. It's even called Redis here. And so now there's a weird dependency where this company says, hey, we want you to buy our cloud, not DigitalOcean or Upstash or whatever. So basically, you either pay us the fees that we demand, or you can't receive any new software updates. So this is where you hear about community forks. Community forks basically say like, hey, we're going to then, use completely different software to replicate this core effect without us having these license restrictions. Now, there's some disadvantages to that for the community. You can understand from a Redis perspective why they would want this. You could also understand why companies that have built these database offerings would be upset. You can also understand why customers like us, who are going to have this, basically these costs passed down to us, are upset, right? Because we don't know if Redis and say DigitalOcean come to an agreement, great for us. If they don't, and now DigitalOcean charges us significantly more for the same exact service, that's obviously worse, right? So all that to say, there's a bunch of meta considerations when you're trying to pick a solution like a database, right? It's not quite so simple as where do you store data. Now, when you're getting started, it is that simple. However, I want to give another example. What was it? Firebase. This is an old kind of horror story that was passed around back in 2018. Gosh, I don't know who decided this freaking neon green. I'm sorry you have to see this. But anyways, this company built this Firebase site, which is basically a backend as a service. If you remember from our previous stream, it's an easy way to bundle authentication and storage, et cetera, all into one place. And the problem is that within these 3 days, they had this massive spike, and they ended up getting charged $30,000 for something that would have cost them less than $100 normally, right? So one of the considerations when you're looking at tech like this, you might think like, wow, this is really easy to get started, but price doesn't scale with you, right? So when we are looking at a project, we could think about price, but in this case, we want to make the project as lightweight as possible. So we actually have a different consideration factor, which is not just what we talked about. You can look at performance, you can look at cost and other things. But from here, we're actually trying to look at, is it local friendly? Can I replicate it easily? Is it cheap? Right? These are the primary considerations for this particular project that we're doing, which is perfect because it's an education project. So we don't want to spend a lot of money on this. We want to get it out the door, and we want it to work on Solana. We want it to run anywhere. So we're looking using Docker, right? We want to be able to access that easily. So we're using this thing called Self or Sealf. I don't know how this guy pronounces it. We're going to be using 1Password so that we can abstract or basically not include plain text passwords inside of our environment variables, right? And then we have this Docker Compose file, which takes these instances of Docker, bundles all this tech into one, and allows you to basically have a front end, have a back end, have a database, be able to query that. And then we need to be able to replicate that to an S3 storage. So let me actually move that up here. So where are we right now? So we know that we have a local workspace, and this local workspace is where our code goes. We know that we have some type of app container. We're going to call this, we have a front end and a back end, just for simplicity. And in this case, we know that this is Next.js, right? Now, again, Next.js, React, not important. These frameworks we can continue to dive deeper into. But if you use any of them, for example, I really like Solid.js. I think this is worth checking out. I think Quick with Astro is a really interesting combination. We can talk a little bit more about those. So we have this front end, back end, and the next piece of this is we need a place to store our data. So we say, in this case, we're looking at local storage. So we'll do, we're looking at SQLite or specifically libsql. And then we need a way that we can actually communicate easily with this. Now, you can make direct calls using SQL. If you don't know, SQL stands for Structured Query Language. So SQL itself is a query language to query data from databases, right? So you have data stored somewhere. Your query language says, give me that data. Your app then reads that. So what we're doing here is we're saying, all right, I want to be able to abstract that process. Now, there are reasons that you to not do what I'm about to say, which is introduce an ORM. And generally those reasons have to do with cascading queries and a bunch of other problems. But bottom line for us, without getting too deep into the ORM space, this works well for our purposes. And generally we find this does. There are some exceptions and some latency considerations when it comes to price data. But if you're dealing with things like account data, people accessing, predictions on Caps One, for example, this isn't really a blocker for us. Now, there are some other like very considerable latency blockers that we have to work through, but those are unrelated to this. Now, going back to this, I kind of offhand said, all right, we're using, in this case, Git and GitHub. So we're using a way to version our software, and we're using github.com to store it, right? And we're just using a very bare bones mono repo, meaning everything is stored in one place. Now, if I look at this front end, back end, you're going to hear a lot in the web space about React. So let's talk about that a little bit. And let's go back, if you've never heard, to JavaScript. So what is JavaScript? So JavaScript, and the reason it took off, all you need to know, is that it was basically the first ubiquitous language for the web. And so a bunch of companies along the way tried to kind of, push themselves into that. But back in the day, what was it? Ben Horowitz, I believe, hired Brendan Eich to build a Lisp-like language, which is a functional language that basically allowed people to kind of replicate the friendly or the structure of Java to a degree, but access that in the web. And for whatever reason, a variety of factors, JavaScript became the ubiquitous standard, and a bunch of other attempted standards failed. And so as a result, it's just become this behemoth. And if you look at, for example, the Stack Overflow diagram, let me actually check in for a second. Just make sure that everything is going well, that there's not a bunch of comments. Cool. Awesome. So if I were to go to Stack Overflow Dev Survey 2023, let's see if we can get some data here. Language. So here you can see languages by popularity, and JavaScript, obviously very popular. Now, what is React? React basically solved the problem for Facebook. So back in the day, and this was if you go back to 2013 when they were having this problem at Facebook, basically they were having issues where you would go to a notifications tab. So like you would go to Twitter, for example, click notifications, and nothing would pop up. Like that is this weird, it's this weird problem where if you expect things to appear for your user and they don't, that's a varying degree of bad. But if your notifications don't appear at all, and you say that they're there and the end user is expected to get this dopamine hit from it, now you've effectively interrupted the core like behavioral psychology aspect that makes social media so addicting. So for companies like Facebook, that was a huge problem to solve. And so they wanted to make sure that their state was really reliable. So they started working on React, which is basically a new way of managing state. Previously, they used PHP, which is very, very popular. There used to be something called LAMP stack or Linux Apache MySQL and PHP. And that was, it's still PHP is, you could say, the most ubiquitous language because a vast majority of the sites on the web today are WordPress, which is, I think they actually ended up switching in recent years. So don't quote me on that. But for many, many years, WordPress was PHP, and PHP was still the most ubiquitous language from a, just in terms of server reach perspective. And now JavaScript has the most developers. So I think JavaScript has dramatically overtaken that. But Facebook had this problem where they're like, we need to stop our reliance on this state issue. So they built their own kind of library. The library, though, basically moved the model where it said, all right, back in the day with this LAMP stack that I just mentioned, you have these kind of, different ideas. What we can use this word, but really what we're saying here is we have server-side render code, which all this means is we have code that sends from server to client, right? And the client will download that each and every time. Now, the JavaScript people came along and were like, hey, you know what we need to do? We need to cut out this server altogether. So what we're going to do is now introduce client-based code. So you started hearing words like SPA or single page application, right? And this single page application was a complete paradigm break. Now, the problem became people started shipping more and more code over the client. So eventually, I'm sorry, this should be JS, React, and whatever other libraries. And so now people were saying, all right, well, this worked for a bit, but now we're having additional issues. So you started hearing things like tree shaking and a bunch of other deduplication terms that basically mean we're going to make the code base lighter to ship to users so that if you're on, let's say, a 3G lower grade network environment, you can access that. Now, if you're like me and you're permanently plugged into 500 megs down, you don't care, but you got to think most of your users are going to be on mobile in questionable network environment, even if they should have fast internet. We all know that we get dead spots in cellular, and so we want our apps to load quickly, right? So it's not just like third world countries with no internet. Even in first world countries, this is a problem where people just have dead spots and they need their code to load faster, require less resources, etc. So this worked for a long time. This was pretty much a standard. And then I don't know Next.js's inception point, but eventually there was a question of, hey, what if instead we shipped some of the code to the server, pre-rendered it, and then we shipped that code to the client? Now, if you're looking at this thinking wait, that sounds super familiar, you're absolutely right. It should, because that is very, very similar to what we came from. So back when I was 16, I started my first web design company. And that was my experience was, I write code on PHP, and that PHP then sends code back to the client. And you would even interpolate, or sorry, you would basically combine, for example, print statements for, from your server to what is supposed to appear in your client. It was very, very primitive, but it worked well, right? Now, let's see. Message, making sure this isn't about. Okay, cool. I'm not good at the streaming thing. If you can't tell, I'm making sure that I'm not missing messages. So when I hear beeps, I get distracted. But so all that to say, we came to this new paradigm. Well, what ended up happening as a result is now a bunch of frameworks wanted to solve both of these problems, right? So you had frameworks like, for example, Next.js that wanted to solve the server-side problem. And you had libraries or frameworks like React that wanted to solve, and by the way, the library versus framework discussion is probably the number one thing that you could fight about on Twitter to if you want a bike shed and make no progress in life, knock yourself out. It means code that is a dependency that runs somewhere, right? People have very different definitions. I tend to stay out of that. It's kind of pointless to me. So if you hear me use the words interchangeably, that's why it doesn't really make a difference to me. But Next.js and React basically rely on one another, right? So that was why these two things, you see them used in conjunction. So if people say Next.js, they're usually referring to React and vice versa. But there were other libraries or frameworks that started to pop up. In this case, you can say Astro is one. And Astro's big innovation, and the reason that I really like them, is Astro said, hey, we will handle SSR for you. We will handle just like you would expect, but we'll also allow you to work directly with React. And so instead of being limited here, though, you can also say run Svelte components. So for the first time, we had this very interesting model where they said you shouldn't have to pick and choose or be locked into a client ecosystem. You should just be able to get started with whatever framework, front end framework you have, and then use one backend framework where you can unify all those components easily, right? And so this is a very interesting kind of problem where you start to see this divergence. And if you were around in the 90s, you remember the big push was for Java. And why Java? Because it was a write once, run anywhere language. And so they introduced the concept of this JVM or Java Virtual Machine. If you're in crypto and you hear the word EVM and you just had a light bulb moment, there you go. And it was so popular that I think Sun ended up spending something like $500 million in advertising. Check it out. It was 50 or 500. I want to say $500 million. I mean, just an insane push to make Java the behemoth that it is today. And it worked. To their credit, it worked really, really well. And then I think they were acquired by Cisco, like many companies back in the day. So the point of this is that all of these frameworks, when you're picking and choosing, if I were to tell you, well, here's a bunch of, let me do another one just to really drive the point home. If I have a front-end client like Solid.js, I can also have something like Solid Starter, which I think, if I remember correctly, I'd have to double check, is the name of their SSR framework, right? Lucidchart recently changed, this is an aside, just a me problem, how these handles attach. And I don't know why, but it's like significantly worse than it used to be. Drives me crazy. But anyways, so Solid Starter and Solid.js go hand in hand, just like React and Next.js do. And let me draw this there so we have some consistency. And so what you can tell from this is like there is this interoperability. But if I were looking from a ubiquity standpoint alone, in other words, we talked about JavaScript's ubiquity winning out. I might look at something like Astro, right? Now, if I wanted to, if I were to do, let's say, Solid.js benchmarks, and I don't know if they still have this on their site. Let's see. Yeah. So you can see, Solid.js. Oh, this is the obligatory. Every person who's ever done a dev stream says this, and it's annoying, but I understand. So, always take benchmarks with a grain of salt, run your own benchmarks. Benchmarks vary depending on use case, et cetera, et cetera. So please no one in the comments shoot me for not pointing out the obvious, et cetera. But anyways, so you can see how Solid compares over time compared to other clients. Now, Solid's interesting, right? Solid, I think, it's really fast. When it says vanilla here, this is comparing to vanilla JavaScript, meaning if you yourself add nothing. What you'll hear from like a lot of people who like Perl Clutch when they compare to things like React having slower performance is they'll say things like, well, yeah, but if you were to roll your own ecosystem, even though vanilla is faster, good luck achieving that robust feature set, blah, blah. And at the end of the day, that's just code. I am a firm believer in developer experience optimization, obviously, but like people who try to like point back and forth to that, it just seems silly to me. If you're looking for performance, Solid.js is a great way to go. Now, that's not the only consideration though, right? If I look at, say, Quick, and I do, gosh, what is that? Let me just look at their hooks for a second. And let me hang on, give me 1 second. Load. What is their preloader called? Gosh, I swear I get dumber every time I stream. Anyways, Quick has a hook, which basically will say, when you scroll into this part of the page, so let's imagine I was here, it's not going to do anything until I stream or scroll, and then it will actually stream bits and pieces of the code in real time, and I can control some of that. And so the significance is that when we talk about this SPA approach, where it was pure client, they kind of combined this server and client approach, but they said, instead of shipping all of this at once, we're going to ship bits and pieces. And React 19 took a very similar approach. They introduced this concept of React what is that? React server components. And so basically this has a similar approach in terms of you stream individual components over the server, whereas Quick allows you to optimize for what actually loads or renders on the page. And so like you have, basically two different ways to kind of accomplish the same thing. And so all that to say that there's a lot of convergence on what these platforms use. So here's why this matters. If you were getting started today and you were to hear about Astro and Next.js, and let's say someone sent you to the Solid.js website and they're like, check out the performance here and whatever, right? You might say, all right, well, I'm going to go in this direction. And then you'll look at and you'll say, but React has more users. And then you look at Svelte and you say, wow, I really like their static compiler. And wow, shout out to Blob because, he's just the biggest Svelte guy I know. And I guess I should just so Tristan doesn't shoot me later, I'll even add a Vue, which is my least favorite framework in the world, but I'll add it here out of respect for him. There you go. So if I were to then look at this and say, all right, where do I get started? I guess none of this matters. If you try to shotgun through each one of these, you'll drive yourself crazy. If you get started with one of these and you assume it's the best, you're going to drive yourself crazy. So how do I approach this? Well, I look and I'm thinking about this from a business perspective. I want to be able to hire the most amount of people to work on the code, right? And so the problem with using something like Svelte or Solid.js or Vue is that the learning curve is higher, right? So even if you make the argument that this other technology is better, I also brought up, for example, Quick, and I think what is Quick's version of this, I think is called Quick City, if I remember correctly. I'd have to double check. So if I were to go look through, and I don't know Vue's, not even going to look it up because I don't like the framework at all, but you can do that on your own time. So if I'm looking at this and thinking like, where do I get started? And I just mentioned a bunch of frameworks and you feel confused, you should, but the reaction shouldn't just be analysis paralysis. You should dive into one and learn it really well. And in my case, when I'm looking at this, like, well, I want to be able to hire the most people, React and JavaScript are the most ubiquitous language and framework, right? So it's the best place for me to get started from a business perspective. Now there's problems with React. You can Google them yourself that we'll talk about in length, why people don't like them. A lot of people have a problem with JSX. Some people don't like the amount of magic that goes into the new React releases, the way they manage state behind the scenes, etc. Some people are not happy with that, right? And so all that to say that some people will look at this and they'll say, well, now that you've added all these features, now we want to simplify and extract and get away from that. And that's perfect because when I talk about these frameworks, I'm not even going to go into Bun. Bun is just a new way of running JavaScript code. It's fast. You should use Bun. Don't use npm yarn. Someone will shoot me for that. Don't care. Use Bun. We have some issues with this. There is a compatibility issue with Got, which is a fetching library we use. But by and large, I would say always use Bun when you can use Bun. So npm enthusiasts can shoot me, but that's how I feel about that. Now, if I'm looking at where I'm getting started with running this code, I know that I'm going to be running, just like we talked about before with containers in the previous stream, I know I'm going to be using Docker Compose to take the containers for, let's say, this Next.js. This is actually perfect because it's the stack we just talked about. And I'm going to basically, let me scroll down to some working code. I'm going to take a script file. The script file is going to allow me to, say, run a Docker container. And that Docker container then is going to be code that I can then access. So you can see here, we actually already have a self container that's running. Now, what is the purpose of this? Well, I want to know that I can run this code in a really lightweight way. So if I look over at this project self, this is basically a self-hosting deployment platform. Now, we talked about Firebase. We've talked about Vercel before. We've talked about Netlify before, right? These are all platforms where I say, hey, I will give you code and you make sure that you deploy it and you run it, right? So if we look back at the original diagram that I shared, you'll remember that we talked about this host, the cloud providers, the infrastructure, the CI/CD, the SCM or GitHub, GitLab, whatever. And if you were here last time, you remember we talked about how services like Netlify abstract all that for you. Now, there are services that I really like KubeFirst, which allow you to use GitOps for Kubernetes. This is what we use for CapSwan. It's a great product, great team. Recommend checking it out. However, this is overkill for a lot of things. You don't want to immediately jump for the Vegeta 9000 for all tools, right? Instead, what you really want is something that fits the job appropriately. And so in this case, what I'm really looking for, and let me move this just so it's a little more clear. I'm actually just going to get rid of that for a second because it doesn't matter. I want something that thinly abstracts this Docker Compose, right? So the Docker Compose here, like, it just gives you the ability to run things in a remote server. That's it. And so what I'm really looking for is a platform that's going to handle that for me. And so there's a few options that we can look at. So one option there is Coolify. Coolify, I know I was dunking on PHP before. This is actually written in PHP. And this has a fantastic open source community backing it, something that we're looking at. But in this case, what I started leaning towards was Self. Now, why? Well, if we look at these two projects, normally, if I was just talking about price and feature set, I would say, give me Coolify, right? But what I actually want is the thinnest possible version. And what I'm really looking for is the ability to have TLS certs, a deployment target, or an easy way to deploy, and pretty much nothing else. I don't care about the rest of it, right? And maybe eventually I need something more robust like Coolify, but at least getting started, I definitely don't. And so let's look at this project and show you exactly how it works. So let's stop there for a second, go back. When we came here, we have this thing deployed on localhost. We are looking to deploy an app. And what that means is it's going to run on the system, give us a domain, etc. Now, this version control system is the GitHub that we talked about, etc. Basically, version control in this case is saying, hey, you can integrate this with an external repository, right? So we have the option to toggle that. And now if I go to new deployment, you can see here that instead of opting for the compose file, which is basically just a wrapper around Docker that allows you to combine multiple Docker containers into one thing. So for example, if you're running a Postgres database, you'd have a Docker container. That just allows you to run the Docker container in a operating system agnostic way. If I were to then turn around and look at, say, a Next.js app, I can run that separately in its own Docker container, right? Now that he doesn't end up using that compose file, he uses a tar gz file, which this tar zip is basically just a standard compression protocol. And then you can see that now it goes through the deployment process. Now, when I'm looking at this, I think that this is a pretty straightforward approach, right? And then when he clicks in there, you can see that now running on the system, we have this welcome Docker localhost. You can see this app. This is exactly what I want. Now, are there fewer features than Coolify? Yeah. Is there a smaller community? Yes. However, for this specific job, it's perfect. And as far as license goes, I don't have to worry about anything. It's a GPL. That's fine for this use case. Again, if you have any questions about licensing when you're getting started with the project, check out license, and it will generally give you a pretty good idea of what you can do. I would say generally you're home free in terms of if you're looking at, a lot of this has great tokenomics distribution, so to speak. Apache and MIT are pretty much like slam dunk. You don't have to think about it. It's just, you're good to go. If you get into things like GPL v3 and different licenses, you have to be mindful of, for example, we gave this Redis example earlier. If I'm relying on something where I'm required to commit code back upstream, or I'm required to apply for an enterprise license. In the case of Redis, they actually get to pick and choose their partners, so they can potentially deny you, right? So that's another problem, is that if they say, you're our partner, so you get these great prices. You're not our partner, sorry, you have to pay whatever we say, right? So in that case, you have to be really mindful of that type of tech decision. But for us, this is perfect, right? So what we've done, and this sounds silly, but we've gone from, we need a place to store the code. We need a place, a way for us to create a workspace. We didn't talk about any of this. We'll probably end up doing, project walkthrough when this is, up and running. We talked about this concept of being able to deploy a Docker Compose file. We talked about some of the considerations there, besides just cost and performance and all that. What are some other, factors that you want to be mindful of? And this libsql thing, this is an alternative. It's a SQLite open source fork. And, we can dive into this maybe a little more. We're coming up on an hour, so I don't want to get into stream replication stuff right now, because I think that's going to be like, it's going to add 30 minutes to this, so let's not. We talked almost not at all about Bun. If you're curious about Bun, go check out bun.sh. Great place to get started. I strongly recommend using this over NPM or Yarn. You can also see what it's like. If you don't know what this is, Bun is, it's basically trying to combine all the disparate parts of an ecosystem that was built around JavaScript. So in the beginning, you had JavaScript, the front end, which only ran in the browser. Then if you'll hear this thing called Node.js. Node.js says, what if we could run JavaScript on the server? Then you had things like Deno, which said, it's actually made by the original guy who made Node, and he wanted to fork it so that he could add some additional assurances around security and sandboxing, things like that. Tried to address some performance concerns, which he made some progress on, but ultimately Bun blew it out of the park. Supabase, for example, is probably one of the most popular projects that uses Deno under the hood. They don't allow Bun support. I had some weird issues with them, but people love Supabase. So check them out if you want an example of that. And so, for example, the Node.js ecosystem will use NPM, the package manager, to basically serve this. So you have Node.js, the runtime, and then you have NPM, the package manager. And Bun says, we are a package manager, we are a bundler, we are a runtime, we are all these things in one, and we're super, super fast. So it's really the left curve approach of I don't have to think about it, it just works. And they, for the most part, I can think of one example with some weird JSON formatting, they're trying to introduce JSON-B formatting to package JSON. Excluding that, I think that basically they have the same mindset of something like Mojo, if you're from the Python ecosystem, where they say, we're going to have total backwards compatibility. We may layer on additional features, for example, Bun Shell is an additional feature that allows you to use JavaScript directly inside of shell files, right? Which I love. But at the end of the day, it's very, very straightforward. And so that's why we use it. So I don't really touch on this just because it's such a obvious choice for me. This, we talked about Next.js and why you might choose some other frameworks. And at the end of the day, really what you're looking for there is, where do I want this code to run? How fast does it need to be, et cetera? And for us too, some of this, it comes down to, for example, we built our entire app in React 4 years ago when we started. I started solo, and I use Create React App, which the React now advises using against. They opt in favor of things like Next.js. And so for us, it would be a huge headache to migrate out of that. Now we could look at something like Astro, which has React compatibility. That was one thing we looked at. Next.js just happens to be paired so closely with React that it's sort of again, just like Bun, it's sort of the left curve decision of hey, here's this ecosystem that's only focused on making these two things work together. Why don't we just go that for our main app? And for some smaller apps that we spin out, maybe we can experiment with other tech and maybe move in a different direction, right? This is the bane of, if you've worked in software for a while, there's always the V2 and the V1 software people. And the V1 legacy software people end up getting stuck a lot of time working on older code that people don't like to maintain. At Caps One, we try to kind of combine, because we're such a small team, right? We try to combine both of those so that you get the best of both, where we're sort of gradually introducing new tech as we go, but we have some hard lines where we can't just jump to the quote unquote V2 version in prod for obvious reasons. And then we briefly touched on this concept of an ORM, which basically means I want to make it easier from a developer perspective to be able to read and write to a database. Now, we are going to come back to streaming replication and ORMs probably in the next stream. But that is more or less an overview of the considerations when I'm looking at building a project. I really think about it from, I'm in a directory. How do I get my code to be stored securely somewhere? And you might think, who cares? Why start with that? A few years ago, deleted, it's probably 7 years ago now, 2,000 lines of code. I rimwrapped the project. I deleted the Git repo. I hadn't pushed it remotely. And I ended up emptying the trash. And some period of time went by. And so for whatever reason, I don't remember why I had issue with rollback, but it was just like a series of events where I was like, what just happened? 2,000 lines of code gone. I was like stressing out of my mind. So for that reason alone, I'm very much in favor of always starting with version control management for this sort of thing. So after that, we didn't talk about, we'll come back into Solana later. By the way, if you're looking for quick TLDRs, not like I know I do a bunch of extemporaneous rambles to give you some background on tech decisions and things that are happening in the space. But if you want more really, really solid Solana tutorials, the official Solana YouTube channel has great tutorials. The only thing that I would add in here is the Solana test validator. If you're looking to test locally, this is nice compared to testnet because you don't have to worry about like, faucet, USDC, that kind of stuff. So anyways, then we talked about, we didn't really go into Docker because we talked about it last stream, but basically you have this concept of a container, and a container says I can run any code that I want inside that container. And then we talked about how we basically bundle that code into, I guess this is really confusing the way that I did this, huh? Let me just do this. Maybe this is a simpler way. Let me do this. That's probably an easier mental model, right? My bad. So we talked about the individual, Docker abstractions for our database. We didn't talk about why we want this database over something like Postgres or MySQL. We just alluded to the fact that we do. We talked about the framework that we're using as well as the runtime. We talked about the framework that we're using for server, and we talked about the framework that we're using for client. And we also gave some examples of other frameworks and client frameworks that work really, really well. That, again, just because we use something, just because you see all your favorite influencers talk about something, or because you see all of them hate something, that doesn't mean the tech is bad or good. It just means it's popular. And generally, a lot of these decisions come down to like how ubiquitous is something. None of us, well, I don't know, none of us, but many of us don't like the fact that Apple is so heavy on anti-repair, right? Or there's some antitrust concerns with these large companies, but at the end of the day, we're still using Androids and Apples, right? And so a similar problem in terms of ecosystem ubiquity. Sometimes there's issues you don't like. You see people complain about it. I complain about Apple. I still have an iPhone. I still have an iPad. I'm streaming this to you on, a Mac M2. So you get the point. And then lastly, I mentioned Prisma. Now we're going to talk a little bit more about Prisma Accelerate. We also have an exciting feature for Capstone coming out, which I'm not going to get into. That's going to rely on a PubSub feature for Prisma. So we'll talk a little bit about PubSub and streaming, how that works. But that's what we're going to get into next week. In 2 weeks. So we're doing the dev stream every other week. And in the interim, what I would encourage you to do if you're looking to get started and you have no preference at this point, I would recommend you go, this is literally the step-by-step process I would do. I would go to bun.sh, type that into your browser, come here, click this copy button, run this. You can go, if you open your Spotlight on Mac or whatever service you use, open up your terminal, run this command. They recently added Windows subsystem support. If you're on Windows, you run a different command. After that finishes installing, you can just confirm, run bun help, and you'll see, hey, this works. And now you can go ahead and, for example, bun create next app, or you can do something like npx create next app, or whatever framework you want to use. But again, I would use bun. And then after that, you end up with this little app. I would start there, and then I would try to build something like one really popular thing on your own that you can try is something like to do MVC. I don't know if they have a Next.js example here, but they do definitely have a React example. And so you can actually come here and see test hello world, and you can build it doesn't need to, this actually looks pretty nice for like a sample project. You can build a much simpler version of this to get started. And then if we go to do MVC, view on GitHub, you will be able to see all of the different versions. Now, I don't actually know exactly where all the code samples are stored for this. Maybe it's in this examples file, React. Yeah, it looks like it. Cool. So you can come here and you can actually get started with this project, and you will be able to see all the code. You can download the entire repo and run it as one. And then if I click into, say, my index, you can see that I have a little React file. There's no extra complexity. But what I would say is, like, if you want to get started with, something like this, really, really easy way to do it is to look at existing code. and then go from there. So reason I'm bringing this up at the end is to say we are going to very likely do a hands-on demo in the next dev stream. And so it would be good to familiarize yourself with some of the pain points around, for example, running your terminal, connecting your app and database and all those things. Like before you start to think about how do I run all this at once, it's good to think about how do I get terminal running? How do I run my package manager, my runtime for the code? How do I store that somewhere? Like we talked about Git, GitHub, whatever. You can create apps just like you would on Facebook or Twitter. So very, very simple to get started. And then from there, publish something. And by publish, I mean find a system that you can deploy the code to. Vercel is an easy way to get started. This is about as left curve as you could expect. And so point is that get started with this, sign up, and try to push your code. You 100%, there are a zillion tutorials that will guide you through step-by-step on how to do that. Once you do that, a lot of the confusion and scariness goes away. And afterwards, when we come back to this next week, we'll talk a little bit more about self-hosting. We'll talk about this self thing that I mentioned. We'll talk more about Docker and how to get started there. And then I don't know if we'll have time, but if we do, then we'll dive into the Solana portion of it. So that concludes our stream. If you ended up watching, thank you for taking the time. If you're tuning in later, thanks for checking it out. Appreciate it. I know we had one guy who reached out, want to make sure that we were actually streaming or recording this to save it for later. Let me go ahead and check YouTube real quick just to make sure I'm not missing any comments. Okay. I don't see anything. I think we're good to go. As always, always happy to chat. Yeah, and if you are looking for places to get started, I guess the last thing I'll end on, always turn to something free and readily available. Do not get sucked into a very expensive boot camp. There are people who do it. They get jobs from it. There's some value. One horror story I want to share is I worked for a company years ago, and we were hiring from one of the top rated boot camps, right? And so one of the concerns with boot camp developers generally is they tend to be lower quality. So they give you kind of a shotgun approach similar to what I did, but generally they'll structure it into a curriculum and they'll say like, here's how you build a to-do app, for example, right? But they'll actually hold your hand through that process. Generally, you'll talk to some type of mentor or senior developer that will give you feedback, and you'll do code reviews and write tests and all that stuff, which is great. It's great because it gives you hands-on experience. The problem is it's a pretty shallow introduction to the entire process, right? So as a company hiring, people generally are hesitant to hire from boot camps. However, on the flip side now, especially with the state of higher education, there's another problem with hiring someone with a 4 to 6 year computer science degree who has no practical hands-on experience. So it's a very opposite end spectrum in terms of the upfront investment. And at the end of the day, I almost lean more in favor of the boot camp. However, the caveat there, going back to this company that I talked to, is I basically said hey, I need to know that we're hiring top-notch talent. And what this person basically told me was, well, we only try to hire out we only push our top 5 to 10%. Now on their site, they make a lot of guarantees about, placements and things like that. But when it actually came down to it, it was clear from a company perspective, our main concern was, hiring these people. And maybe this lady was just saying that to get us in the door or whatever, because they charge, I don't remember their fee. It's let's say 10 to 20 grand per developer. And, if you look at recruiting costs, that headhunting, that's not super uncommon in tech. So it was an acceptable, we're trying to onboard 5 to 10 devs. We don't want to go through the recruiting process ourselves. We outsource that. It makes sense, right? However, the problem there was it became clear to me that she invited us to come check out, and she's like, yeah, you can actually walk around and see how they're doing. It almost felt like looking at monkeys in a zoo. We're going to go watch some other people code and figure out based on that who we vibe with the best, which I understand the value that you do want to have. And, video calls are great. In-person meets are great. But I share this story just to make the point that this was how what's that saying? How the hot dogs cook. That's not it. But the saying I'm trying to refer to, hopefully. It's how things are done behind the scene. And it was shocking to me that this company was charging a lot of money up front to these, would-be developers, and as a company trying to hire from that pool, being told like, don't worry about it. We're not worried about those bottom 90% performers anyways. So it's like, it's a very, very weird problem. And I don't know what it's like today. This was, years ago. Maybe the state of boot camps have improved. I would just be mindful of people trying to prey on you. There's enough free education materials. For CapSwan, we may do a paid course at some point, but it would be a lot of work, which is why I've never done one before. I've had a bunch of people ask me to do one, but it would be probably like 100+ hours of development time to get it going. Not something I'm looking to do. I have too many things on my plate. But if these streams go well, you guys really like it, we continue to grow, then that may be something we look at. But the bottom line is, if we charge something like, let's say $100 for that, it's very different than you paying for curriculum costs versus you paying, $10,000 to $20,000 for a boot camp for basically the same experience, right? So just be mindful. There are good boot camps, I'm sure. Just double check. And as always, YouTube is your friend. You're going to get a lot of free resources. So thank you for stopping by. We do recap every Thursday, 11 a.m. Pacific, 2 p.m. Eastern. We rotate. So we do a dev stream, and then we do a product stream. We do a dev stream and then a product stream. And that's just how it will continue to go until the end of time, or Ace tells me differently. So anyways, hope to see you guys around. And as always, happy to answer any questions. I lately have not had a ton of time for a lot of technical questions. I put together a little dev group a while ago. Haven't spent, a bunch of us have been busy since all the insanity with crypto recently. But, if you're looking for more hands-on community where you can ask dev questions, reach out, DM me, and, I'll run it by the group. And if it seems like you're an upstanding, anon, then happy to add you. And that just makes it easier for us to make sure you're getting feedback that you care about. So, if you guys have any questions, please reach out. Thanks. Bye. Now the awkward part where I try to find the end stream button after I've said bye. And I need a Zoomer to teach me how to stream. Found it. All right. See you for real this time.